Liquid nitrogen is nitrogen in a liquid state at an extremely low temperature. It is produced industrially by fractional distillation of liquid air. Liquid nitrogen is a colorless clear liquid with density of 0.807 grams per milliliter at its boiling point and a dielectric constant of 1.43. Liquid nitrogen is often referred to by the abbreviation, LN2 or LN, or LN, and has the UN number 1977. Liquid nitrogen is a diatomic liquid, meaning the diatomic character of the covalent N bonding in N2 gas is retained even after liquefaction. At atmospheric pressure, liquid nitrogen boils at a 196 degrees Celsius and is a cryogenic fluid that can cause rapid freezing on contact with living tissue. When appropriately insulated from ambient heat, liquid nitrogen can be stored and transported, for example in vacuum flasks. Here, the very low temperature is held constant at 77 K by slow boiling of the liquid, resulting in the evolution of nitrogen gas. Depending on the size and design, the holding time of vacuum flasks ranges from a few hours to a few weeks. The development of pressurized super-insulated vacuum vessels have enabled liquefied nitrogen to be stored and transported over longer time periods with losses reduced to 2% per day or less. Liquid nitrogen can easily be converted to a solid by placing it in a vacuum chamber pumped by a rotary vacuum pump. Liquid nitrogen freezes at 63 K. Despite its reputation, liquid nitrogen's efficiency as a coolant is limited by the fact that it boils immediately on contact with a warmer object, enveloping the object and insulating nitrogen gas. This effect, known as the Leiden-Frost effect, applies to any liquid in contact with an object significantly hotter than its boiling point. More rapid cooling may be obtained by plunging an object into a slush of liquid and solid nitrogen rather than liquid nitrogen alone. Nitrogen was first liquefied at the Jagiellonian University on April 15, 1883 by Polish physicists, Zygmunt Rakubczewski and Karol Olszewski. Uses: liquid nitrogen is a compact and readily transported source of nitrogen gas without pressurization. Further, its ability to maintain temperatures far below the freezing point of water makes it extremely useful in a wide range of applications, primarily as an open-cycle refrigerant, including, in cryotherapy for removing unsightly or potentially malignant skin lesions such as warts and actinic keratosis, to store cells at low temperature for laboratory work, in cryogenics, in a cryophorus to demonstrate rapid freezing by evaporation, as a backup nitrogen source in hypoxic air fire prevention systems, as a source of very dry nitrogen gas, for the immersion, freezing, and transportation of food products, for the cryopreservation of blood, reproductive cells, and other biological samples and materials, to preserve tissue samples from surgical excisions for future studies. As a method of freezing water and oil pipes in order to work on them in situations where a valve is not available to block fluid flow to the work area, method known as ice plug are nowadays replaced by electrical heat pumps, in the process of premession, a way to dispose of the dead, for cryonic preservation in hopes of future reanimation. To shrink weld machinery parts together, as a coolant, for CCD cameras in astronomy, for a high-temperature superconductor to a temperature sufficient to achieve superconductivity, for vacuum pump traps and in controlled evaporation processes in chemistry. To increase the sensitivity of infrared homing seeker heads of missiles such as the SCHLA-3, to temporarily shrink mechanical components during machine assembly and allow improved interference fits, for computers and extreme overclocking, for simulation of space background in vacuum chamber during spacecraft thermal testing. In food preparation, such as for making ultra-smooth ice cream. See also molecular gastronomy. In container inerting and pressurization by injecting a controlled amount of liquid nitrogen just prior to sealing or capping, as a cosmetic novelty giving a smoky, bubbling cauldron effect to drinks. See liquid nitrogen cocktail, as an energy storage medium. Branding cattle. Culinary use of liquid nitrogen. The culinary use of liquid nitrogen is mentioned in an 1890 recipe book titled Fancy Ices authored by Mrs. Agnes Marshall, but has been employed in more recent times by restaurants in the preparation of frozen desserts, such as ice cream, which can be created within moments at the table because of the speed at which it cools food. The rapidity of chilling also leads to the formation of smaller ice crystals, which provides the dessert with a smoother texture. The technique is employed by chef Heston Blumenthal, who has used it at his restaurant, The Fat Duck, to create frozen dishes such as egg and bacon ice cream. Liquid nitrogen has also become popular in the preparation of cocktails because it can be used to quickly chill glasses or freeze ingredients. It is also added to drinks to create a smoky effect, which occurs as tiny droplets of the liquid nitrogen come into contact with the surrounding air, condensing the vapor that is naturally present. Safety. Because the liquid-to-gas expansion ratio of nitrogen is 1/694 at 20 AA degrees Celsius, a tremendous amount of force can be generated if liquid nitrogen is rapidly vaporized. In an incident in 2006 at Texas A&M University, the pressure relief devices of a tank of liquid nitrogen were malfunctioning and later sealed. As a result of the subsequent pressure buildup, the tank failed catastrophically. The force of the explosion was sufficient to propel the tank through the ceiling immediately above it, shatter a reinforced concrete beam immediately below it, and blow the walls of the lab 0.1-0.2 m off their foundations. Because of its extremely low temperature, careless handling of liquid nitrogen may result in cold burns. As liquid nitrogen evaporates, it will reduce the oxygen concentration in the air and might act as an asphyxiant, especially in confined spaces. Nitrogen is odorless, colorless, and tasteless and may produce asphyxia without any sensation or prior warning. A laboratory assistant died in Scotland in 1999, apparently from asphyxiation caused by liquid nitrogen spilled in a basement storage room. In 2012, a young woman in England had her stomach removed after ingesting a cocktail made with liquid nitrogen. Oxygen sensors are sometimes used as a safety precaution when working with liquid nitrogen to alert workers of gas spills into a confined space. Vessels containing liquid nitrogen can condense oxygen from air. The liquid in such a vessel becomes increasingly enriched in oxygen as the nitrogen evaporates, and can cause violent oxidation of organic material. Production. Liquid nitrogen is produced commercially from the cryogenic distillation of liquefied air or from the liquefaction of pure nitrogen derived from air using pressure swing adsorption. An air compressor is used to compress filtered air to high pressure. The high-pressure gas is cooled back to ambient temperature, and allowed to expand to a low pressure. The expanding air cools greatly, and oxygen, nitrogen, and argon are separated by further stages of expansion and distillation. Small-scale production of liquid nitrogen is easily achieved using this principle. Liquid nitrogen may be produced for direct sale, or as a byproduct of manufacture of liquid oxygen used for industrial processes such as steelmaking. Liquid air plants producing on the order of tons per day of product started to be built in the 1930s but became very common after the Second World War. A large modern plant may produce 3,000 tons a day of liquid air products. See also, industrial gas, computer cooling, cryogenic nitrogen plant, liquid nitrogen vehicle, references.